All right, this is section 4.1 on properties of linear functions and linear models. We're going to graph linear functions. We're going to use average rate of change to identify linear functions, determine whether our linear function is increasing, decreasing, or constant, and build linear models from verbal descriptions. All right, let's get started with this. Linear function is a function of the form f of x is equal to mx plus b. Or another way to think about this is y is equal to mx plus b. And I know what you're thinking. Yes, this is basically slope-intercept form. You already know this. So when we're working with functions, yes, we like to have this solved for our y. And right, instead of the y, oftentimes you'll see the f of x. The m is still going to represent our slope. The b is going to represent our y-intercept. But I guess to be a little bit more precise, it's actually not just the y-intercept, but it's actually the y-coordinate of our y-intercept. Because remember, I like to write y-intercepts as ordered pairs. So I'm just going to write that down. B is the y-coordinate of the y-intercept. All right, theorem. Increasing, decreasing, and constant linear functions. A linear function f of x is equal to mx plus b is increasing over its domain if its slope m is positive. It is decreasing over its domain if its slope m is going to be negative. And it's constant over its domain if the slope m is 0. In other words, that means it's a horizontal line. So why don't I just go ahead and draw some quick examples over here on the side. If a line has a positive slope, it's going to go upwards from left to right, which means it's increasing. And I apologize that this didn't come out in the video. I didn't realize that this part was going to get cut off when I was writing this out. Let me scoot this over. There, that looks better. Okay, if it has a negative slope, then when you look at a line from left to right, it's going to go downward. And we're going to say that this function is decreasing. And if it has a 0 slope, or in other words, it's a horizontal line, then we call this function constant over its domain. So those are the 3 different situations that can happen with a linear function. Let's go ahead and practice working here with 2 linear functions that we have here. Let's find the slope and the y-intercept, and then let's use the slope and the y-intercept to graph the function and determine if the function is increasing, decreasing, or constant. So looking at this, I can tell that my m is going to be equal to negative 2/3 and my b is equal to 4. So what that means that my slope is equal to negative, I could write this as negative 2 over positive 3. If I write this as negative 2 over positive 3, then this negative 2 means I'm going down 2 units for every 3 units that I go to the right. And I'm just going to draw this to help remind me. Positive y, positive x, negative y, and positive x means I go down and to the right. Or I could write this as a positive 2 over a negative 3, which means I would go up 2 and then to the left 3 units, right? And of course, we could also write this with the negative in front of the fraction bar. Either one of these 3 representations is correct for writing the slope. And the y-intercept is going to be 0, 4. So let's go ahead and get started with this. I'm going to start off with the y-intercept. That is like a starting point that's going to tell me where I need to start from. So we're going to go to 0, 4, plot that point. I'm going to label it, and I'm going to go down 2 and over 3 to the right, and that's going to land me here at 3, 2. I'm going to draw my line. I'm going to make sure I extend my line all the way to the ends of the graph. It has arrows on the ends of the line. I'm going to label my line with the equation of that line. These are the kind of things I like to do because it shows that I have confidence in my work. It shows it looks nice when I'm, trying to draw my graphs, and it looks like I know what I'm doing. So h of x is decreasing in this case because if you look at this line, if we go from left to right, the line is going downward, right? Or in other words, it has a negative slope. I wrote this first before I narrated, and I wrote D graph because I didn't think it had in the directions graph. It wasn't until I was reading it out loud right now that I realized it did already say to graph in the directions. But that's okay. We could put in that D graph just for extra emphasis to make sure we graph these functions. All right, B, f of x is equal to 2, or in other words, y is equal to 2. When you have something written in this form, this is talking about a horizontal line. If you needed to come up with a few points, you're only allowed to choose 2 for y, and you could choose any numbers you want for x if you needed a few points to help you guide you in plotting this line. Another way you could write this is as f of x is equal to 0x plus 2. In this case, we can see here that the slope is equal to 0, and our y-intercept is going to be 0, 2. Let's go ahead and plot that point 0, 2 first. And actually, let me write down first that f of x is going to be a constant function. So I can just get that out of the way, and I could just box all of this in. And then we could focus just on our graph. All right, I'm going to go to 0, 2 and plot a point. And I'm going to draw a horizontal line going right through this point. I always tell my students you need at least 2 points to plot a line or graph a line. So I'm just going to go ahead and label one more point just to make sure it's clear that we have here 2 points for this line. Even though it's kind of clear that this is a horizontal line, but just to be on the safe side, I plotted my 2 points and I labeled them. All right, let's go to the next problem. Oh, and I apologize. I was kind of just doing a little bit of scratch work before I did my video here, and I forgot to erase all of this. Number 2, suppose that f of x is equal to 3x plus 5 and g of x is equal to negative 2x plus 15. Graph y equal to f of x and y equal to g of x and label the points that represent the solution to the equation f of x is equal to g of x. Well, what I decided to do is I decided to actually write the equation first and solve the equation first, even though it did say to graph first. And I got x is equal to 2. That's okay if we decided to solve first. We're going to go ahead and do the graph right now anyways, right? So this only helps reaffirm the fact that we know that our 2 lines here should intersect at x equal to 2. So let's go ahead and graph this now. F of x is equal to 3x plus 5. I'm going to use what I learned from slope-intercept form. I'm going to use my y-intercept and the slope to help me graph this. So I plotted a point here at 0, 5, and I went up 3 and over 1 to the right. And there's my line. Now, unfortunately, what I did here for this line, I'm not going to be able to do for the next one because it says that g of x is equal to negative 2x plus 15. And I can't get to 15 for my y-intercept because my graph here that I created is too small. So what I'm going to do for the second linear function is I'm going to do a table of values. I'm going to come up with 2 points because any 2 points in space determine a line. And I'm going to come up with 2 x values that I know will give me points that will land within this graph. So looking at this equation, g of x is equal to negative 2x plus 15, I'm thinking of numbers that I can multiply by negative 2 and add to 15 that will land within those y values that are going to be within that 10 range, up to 10. So 3 and 4 I think will work. Let's try it and see what we get. G of 3 is equal to negative 6 plus 15. which is 9. Yes, 9 is going to fit in my graph nicely. And g of 4 is equal to negative 2 times 4 plus 15, which is negative 8 plus 15. It's just going to give me 7, and that's going to fit nicely in my graph as well. So sometimes you need to do things like this where maybe, yes, we can't get to that y-intercept. And, that's okay, because we know of other methods that we can do here. And of course, you guys can use your graphing calculator to also double check your work. And I apologize here. I'm still learning how to use this tablet. I'm still struggling with it. It's not like my Fujitsu. And every day I remember this, but I am trying to be patient. All right, there is my line. I'm going to label the equation of my lines. Notice how I extended my lines to the ends of the graph. I drew arrows on the ends. I'm labeling my points with my ordered pairs. So my answer to, when is g of x equal to f of x, it's basically the x value or the x coordinate of the ordered pair where they intersect. So looking at this, I can probably tell here, right? I already got the work over here to the side. I can tell it's supposed to be at x equal to 2, But I can also tell by looking at the graph that I can tell it looks like it's going to intersect where x is equal to 2. All right, B, solve f of x is less than 0. You're basically looking for where are all the y values for this f of x function that are going to be negative or less than 0. So what are the x values that will produce those y values? It says strictly less than 0. So I'm going to draw an open circle right here on this x value that's right on top of the x-axis. And then I'm going to shade everything to the right to the left in green, because those are the x values I want. Now, what is that x value exactly there? I can't really tell what it is. It looks like it's going to be a decimal or a fractional value. So I'm going to have to do this algebraically, because the graph, unfortunately, sometimes the graph, it's very difficult to try to get like an exact answer when you've got answers that are fractional or decimal. I can't figure out what the x coordinate is. But if I set this up as an inequality and I solve it algebraically, I'll be able to get that x value exactly. So we get 3x is less than negative 5, divide both sides by 3, and x is going to be strictly less than negative 5/3. So that's going to be the open interval from negative infinity to negative 5/3, or the set of all x such that x is less than 5/3. Either one of these representations is fine for the answer. So I'll put a little or here in between them. One is in interval notation and one is in set builder notation. All right, and because it says strictly less than, that's how I know it's an open interval. That's how I know it's a parenthesis that I'm going to use, because it says strictly less than. There's no equal sign there. Now in the next problem, in C, there is an equal sign, right? So it's asking, when is f of x greater than or equal to g of x? When is f of x, when are the y values basically above the g of x function? So I can tell here where x is equal to 2, and then everything that is to the right of x equal to 2 are going to produce y values that are going to land above the g of x function. So another way to do this is to solve it algebraically, replace f of x and g of x with what it's equal to, and solve this inequality. I'm going to move my x's to the left, because whenever I solve an inequality, I like to have the x's on the left. It's easier for me to read the inequality. So I'm going to solve this. I get 5x is greater than or equal to 10. Divide both sides by 5, and I get x is greater than or equal to 2. So basically that's my answer. It's going to be the half-closed interval from 2 to infinity, or the set of all x such that x is greater than or equal to 2. Let's box that in. All right, let's go on to the next problem. Use average rate of change to identify linear functions. 3, determine whether the given function is linear or nonlinear. If linear, determine the equation of the line. Oh, you know what? I didn't finish looking at this right now. I can tell you guys. I only figured out if it was linear or nonlinear, and I did not find the equation of the line. I'm going to have to do that part right now and edit this video as I'm doing this. Okay, so first off, we're going to find the formula for slope. Here, we're going to use the formula for slope, and we're going to have to use it for each one of these pairs, or sets of ordered pairs, and figure out if the slope is the same. Let's start off with the first 2 ordered pairs. -2, -4, and -1, comma, -3.5. Let's call this first one x sub 1, y sub 1, and the second ordered pair x sub 2, y sub 2, and let's substitute. So I'm going to go ahead and substitute here for my first time I'm using my formula for slope. And it looks like once I substitute these values, I'm going to get -3.5 plus 4 and 1. Oh, sorry, that's a -1. I forgot the negative on the 1, but I'm going to remember it right now. That was supposed to be a -1. So let's go back and write it in there right now. There we go. That's much better. -1 plus 2. So that's going to give me 0.5 divided by 1, which is going to be equal to 0.5. So that's the slope I need to get for all of no matter which ordered pairs I use here. I've got to get that same exact slope. So let's check the next 2 sets of ordered pairs and see if I get the same slope for that. All right, so the next set of ordered pairs here, I got -3.5 minus, looks like -3. And then I'm going to have -1 minus 0. So this is going to be -3.5 plus 3 over a -1, which will basically give me -0.5 divided by -1, which is +0.5. So far, so good. Got to keep going. Let's check these sets of ordered pairs here. We're going to have -3 minus -2.5 over 0 minus 1. This will give me -3 plus 2.5 over -1, which will basically give me -0.5 over -1, which is +0.5. And then the last set of ordered pairs here. So this is going to be -2.5 minus a -2 over 1 minus 2. So it's -2.5 plus 2 over 1 minus 2. So this will be -0.5 over -1, which is +0.5. I got the exact same slope for all of these. What that's basically telling me is that it's telling me that this is a linear function. So I can write this equation of this line. So let's go ahead and do that step now. Let's write the equation of this line. All right, we left off on writing the equation of the line. We're going to write this in the form f of x is equal to mx plus b. What's our m going to be replaced with? Our m is the slope. So every number that we got over here, which was the same value, represents our slope, our m. Our b. Our b is already given to us in our table of values. Here it is, 0, -3. So the -3 represents the y-coordinate of the y-intercept, which is our b. So we can just go ahead and write that in. In the future, in case they don't give you the b there, you could figure it out by using the slope here and one of these points, and you could rewrite it using point slope form into slope intercept form in case they don't give you the b value, they don't give you the y-intercept in the future, just in case that happens. Okay? All right, the next problem, b. We're going to do the same thing we did last time. We're going to use the formula for slope, and we're going to find the slope using each one of these sets of points. Here I made a mistake. Let me erase that. So this should have come out to -2 plus 1 in the denominator, which would have been -5 over -1, which is a +5. Now when I do the next two sets of points to get the slope, this -1, -3 and 0, 0, I end up with -3 divided by -1, which is +3. These two values are different. They're not the same. Because they're different, that tells me that these two sets of ordered pairs here, when I came up with the slope, because they're different, there's no way this can be a linear function. So this is going to be a non-linear function. This function is I'm trying to write the word non-linear. Let me try that again one more time here. Non-linear. Ah, yes. Very nice. Very nice. Since it's non-linear, I don't have to write down the equation, because we're only writing down the equation if it's linear. Let's go ahead and do this next problem right here. This next problem says, number 4, suppose the quantity supplied S and the quantity demanded D of hot dogs at a baseball game are given by the following functions, where P is the price of a hot dog. Find the equilibrium price for the hot dogs at the baseball game. What is the equilibrium quantity? Let's start off with equilibrium price. Let's just talk about it. What is this? What does this mean? The equilibrium price of a product is defined as the price at which quantity supplied equals quantity demanded. So that's what the equilibrium price means. So in order to find this, what I would have to do is I would have to take my two functions here, my S of P and my D of P, and I would need to set them equal to each other. So S of P equals D of P. I'm going to replace those with what S of P and D of P are equal to, and I'm going to solve this equation in one variable. All right, so I'm going to move all my P values over to the left and all my constants, anything without a P, to the right. I'm going to solve for P, divide both sides by 4,000, and I'm going to get P is equal to 3. Now let's recall, what does this mean? We said P represents the price of a hot dog. So then this means that the equilibrium price for a hot dog is going to be $3. It's also asking for a second part here. What is the equilibrium quantity? In order to find this, all I have to do is just basically substitute 3 for P and solve. And I could use either one of the two equations, because this is where the two equations are equal to each other. They both have to have the same y value here. So a good way to check your work is to substitute P equal to 3 into both equations, and you should end up with the same for both. So S of 3 and D of 3. Doesn't matter which one of the two equations you use, it's got to have the same y value, right? If you're really lazy, you could just do one, but if you want to check your work, you should do probably both of them to check your work. All right, let's substitute into the S of P first. So S of 3 is going to be equal to negative 2,000 plus 3,000 times 3 is going to give me 9,000. And then negative 2,000 plus 9,000 is 7,000. So that's basically telling me that we're going to have 7,000 hot dogs as our equilibrium quantity. Let's go ahead and substitute into the D of P, just to double check this to make sure that we did this correctly. So D of 3 is going to be equal to 10,000 minus 1,000 times 3. So this will be 10,000 minus 3,000. And so D of 3 is equal to 7,000. The exact same quantity. So yes, this makes me feel very confident of my work. We also could have put this into our graphing calculator. We could have graphed both of these functions, right, since they're linear functions, and we could have looked for the point of intersection. So, and that would have given me if I would look for the y coordinate of that point of intersection, that would have given me this amount. And the x coordinate would have given me the equilibrium price. So the equilibrium quantity is 7,000 hot dogs. Determine the prices for which quantity demanded is less than quantity supplied. When I see words like less than, quantity demanded is less than quantity supplied, that makes me think of inequalities. So I'm going to go ahead and rewrite this as an inequality. D of P is less than S of P. And then let's substitute. What is D of P equal to? It's equal to 10,000 minus 1,000 P. And then we're going to set that less than, strictly less than, because it didn't say equal to. So strictly less than negative 2,000 plus 3,000 P. And we're going to solve this inequality. Let's go ahead and get all our P's to one side. Whenever I'm working with an inequality, I really like to get my variables on the left-hand side because it's just easier for me to read it as an inequality. It makes more sense. So I'm going to move all the numbers without variables to the right, and everything with a P on it is going to get moved to the left. I'm going to end up with negative 4,000. P is less than negative 12,000. Divide both sides by negative 4,000. But what happens when you divide both sides of an inequality by negative? That's right, the inequality flips. You have to invert that inequality. And we will be left with P is greater than, strictly greater than 3. So what does this mean? Well, the problem said determine the prices for which quantity demanded is less than quantity supplied. So if P is greater than 3, it basically means that the quantity demanded is going to be less than quantity supplied. People are not really going to want these hot dogs because they're going to be too expensive if you make the price greater than $3. So when the price per hot dog is greater than $3, then quantity demanded will be less than quantity supplied. C. All right, and let's box that in. Okay, C. What do you think will happen to the price of hot dogs if the quantity demanded is, and there was a little, I made a mistake here. So if you guys could fix it on your handouts, if you guys printed the handout that I had uploaded, this should have been an is here. I think it just had like a capital I. So make sure you replace that with an is. What do you think will happen to the price of hot dogs if the quantity demanded is less than the quantity supplied? Well, you know what I think will happen? I think that the price of hot dogs is going to have to go down. They're going to have to lower the price of hot dogs. So in other words, the price of hot dogs will decrease. Because people aren't buying the hot dogs, right? If the quantity demanded is less than the quantity supplied, and then what's going to happen is you're going to have a lot of hot dogs left over that people aren't going to want to buy, and they're going to go bad. So you're going to have to lower the price, and that way more people will want to buy them, and you'll be able to sell them. All right, let's go to the next problem. Suppose that a company, number 5, suppose that a company has just purchased a new machine for its manufacturing facility for $120,000. The company chooses to depreciate the machine using the straight line method over 10 years. A, write a linear model that expresses the book value V of the machine as a function of its age X. Linear model, that should make you think of that f of x is equal to mx plus b form. We need two things here. We're going to need to know what's the slope, what's the y-intercept, right? And I'm going to replace the f with a v because they're asking me to express the book value v of the machine as a function of age x. Since they're keeping the age as a value with the variable x, I can keep the x alone, but I'm just going to replace f with a v. And m is going to be replaced with the slope. I don't know what the slope is, but we're going to have to figure it out. We can figure this out if we take our amount that the machine cost, the $120,000, and we divide it over the 10-year period that they're telling us it's going to depreciate. So we're going to divide 120,000 by 10. That's going to give us our slope. So slope is going to be equal to, oh, I don't have enough space here to write. Let me write below here. 12, it's going to equal 12,000. So that's what I'm going to replace with the slope. But wait a minute, because it's depreciating, it says it's going to depreciate. We know that that means that when we're talking about this linear function, that the slope has to go down or decrease. The function has to decrease. So I'm going to actually make this a negative slope since they told me that this machine is going to depreciate over time. It's going to have to be a decreasing function. So we're going to write negative 12,000x. Now we also need to have the y-intercept. What is the y-coordinate of that y-intercept going to be? Well, we got to think about, well, what's the value of this machine at 0 time, right? When it's brand new. If we just purchased this machine and it's brand new, how much is it worth? How much did it cost? It cost $120,000. This is going to be our linear model or our linear function. All right, B, what is the implied domain of the function found in part A? So the implied domain is going to be from like when it was brand new to when it's at the end of whatever it depreciates. So it said it's going to depreciate over 10 years. So X represents the age in years. So it can start at 0, right? 0 years when the machine is brand new. So I'm going to write 0 years, machine is brand new. And I apologize, it went off of the screen here, but I'm telling you what that says. It says brand new. And at the end of 10 years, it's basically going to be, not worth anything. So it's only going to last for 10 years, the value of this machine. So it's basically going to be the closed interval from 0 to 10. If we're going to write that in interval notation. Or another way we could write this, we could also write this in set builder notation, right? The set of all x such that x is greater than or equal to 0 and x is less than or equal to 10. The next one, it says C, graph the linear function. Okay, to graph this, I'm going to have to label my axes. My x-axis, I'm going to label that as x, and my y-axis is going to be labeled as v of x. X represents the age of the machine in years, whereas v of x is going to represent the value of the machine. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the value, I'm also going to separate this into 10 parts here. So if I divide 120,000 by 10, then this is going to go up by increments of 12,000. So for our very bottom tick mark here, or first let me show the work here, 120,000 divided by 10 is going to give me 12,000. So the y-axis is going to increase in increments of 12,000. So 12,000, 24,000, 36,000, 48,000, 48,000 plus 12,000, 60,000, 72,000, 84,000, 96,000, 108,000, and then up to 120,000. So at age 0, the machine is worth $120,000 because it's brand new. So that's going to be one of our ordered pairs here, 0, 120,000. At 10 years, the machine's going to be worth nothing. It's going to be worth 0. So all you need to create a line, or a line segment in this case, 2 points. So we can connect these 2 points, and this represents our linear function. Okay, I think we're ready to go on to the next question here. We got all the graph done. Next question, D. What is the book value of the machine after 8 years? Let's see if we can use our graph to help us do this. Here's 8 years. So if I were to line this up here, see what does it look like it matches up with? Oh, this isn't a very good freehand sketch. It doesn't look like it lines up with the right one. So depending on your freehand sketch, maybe you're going to be able to get it to line up with the right value, or maybe you won't, like me. It's supposed to line up with the 24,000. But another way we can show this, just in case you're looking at the graph and you're saying, my graph doesn't look very accurate, like I'm not able to get it to line up exactly with the right value. What's another way I could do this problem? You could take your v of x linear function that we came up with, v of x is equal to 12,000x plus 120,000, and you could substitute x equal to 8. V of 8 will be equal to negative 12,000 times 8 plus 120,000. And this will also get you that value, just in case your graph is a little bit off and you're having a hard time figuring this out. Let's show this work here below D so I can show where the work is supposed to go. V of 8 is equal to negative 12,000 times 8 plus 120,000. V of 8 is equal to negative 12,000 times 8 is going to give me negative 96,000 plus 120,000. If I add those two numbers together, I'm going to get V of 8 is equal to 24,000. And remember what this represents. Whenever you're talking about word problems, you always need to label the units. So what does this represent? Is this cubic centimeters? Is this miles per hour? This represents what? It represents dollars. It represents the value. So the book value of the machine, right, after 8 years will be $24,000. And let's box that in. All right, so we left off here with E. When will the machine have a book value of $72,000? Okay, looking up here, let's look at the Y values and let's look and see when the Y values will be equal to $72,000. So it looks like it's right here. Now, once again, depending on the sketch you drew of this graph, it might be very easy to tell where this value lines up, or it might not be able to tell where this value lines up. It looks like it's supposed to line up here at x equal to 4. That's where it looks like it's supposed to line up. And if you were to put this, once again, that function, if we would have put it into the graphing calculator, we could have looked at the table of values and we could have gotten that answer very quickly. If we're doing this by hand, what I'm going to have to do is I'm going to have to replace v of x, our y value, with $72,000. So I'm going to replace this whole v of x with 72,000. And we're going to solve this equation for x. So if I want to isolate my x, I'm going to have to subtract 120,000 to both sides of my equation. And these are going to cancel out. 72,000 minus 120,000. That's going to give me a negative value. So that'll come out to a negative 48,000 is equal to negative 12,000x. Let's divide both sides by negative 12,000. And that's going to give me x is equal to positive 4. So that's exactly what I thought it was going to be by looking at my graph. But now we are 100% sure, so we're going to write this out. When will the machine have a book value of $72,000? It looks like after 4 years, the machine is going to have that book value of $72,000. All right, so that's it for 4.1. Good job for hanging in there and watching all of 4.1. So that's going to be it for this particular section. And you could have also just written, I guess, 4 years and boxed that in, but it's good if you write down the whole thing.